Okay, I just wanted to run through this last part again since we kind of rushed through it in class. So talking about a cost, linear cost, revenue, and profit functions. So at a summer art show, a vendor sells lemonade for $2 a cup. The cost to rent the booth is $120. Furthermore, the vendor knows that the lemon, sugar, and cups collectively cost 50 cents for each cup of lemonade produced. So write a linear cost function to produce X cups of lemonade. So the cost function, remember, includes the fixed costs and the variable costs. So C of X, where X is the number of cups made. How much is it to make the cups? This is what we're talking about, cost. All right. So 50 cents per cup as you're making them for lemons, whatever, the cup. All right. There's a $120 fixed cost for the booth. It doesn't matter how many cups of lemonade you make, that's what you're going to have to pay. So that is 120. That's our fixed cost. And then our variable cost is 50 cents per cup, and it depends on how many cups you make. So 0.5x. That's our cost function. That's how much it's going to cost, the rent and the amount for each cup. Then B, write a linear revenue function for selling X cups of lemonade. So that's how much money you're going to make. And that will be $2 a cup. Every cup you get $2 for when people buy them, right? Then your profit function, that is where you take your cost and your revenue together and you say, okay, I took in this much money. However, I have to subtract this, my costs must be subtracted for me to tell what my profit is. So revenue minus cost is your profit. And then it says how much profit will the vendor make if 50 cups of lemonade are sold. So that is a profit function question because you're wanting to know how much money did you make if you sold 50 cups. So P of 50 is equal to 2 times 50 minus 0.5 times 50 plus 120. And if you do that, that's 100 minus 25 minus 120. And that is going to be a negative number. It's going to be negative $45. So that means you lost money. If you only sell 50 cups of lemonade, you're not going to make any money and you're actually going to be in the hole. So yeah, that's not good. You got to sell more than 50 cups. So E, what if you sell 128 cups, then the profit for 128 cups is going to be 2 times 128 minus 0.5 times 128 plus 120. So here you're going to have 256 minus 64 minus 120. That's going to be $72. So that's a profit anyway. And then F, what is the break even point? So for F, you want your costs to equal your revenues. That means you didn't lose any money, you didn't make any money. It's break even. So you want C of X, your cost, to equal your revenue. And that would mean that 0.5x plus 120 is equal to 2x. And so if you subtract 0.5x on both sides, you're going to have 120 is equal to 1.5x. So x is going to be 80. You'd have to sell 80 cups to break even. And so here you can see a graphic view of what's going on here. So the cost function, 0.5x plus 120, is this blue line. So that's what that line looks like. And then the revenue function is this purple line. That is the line y equals 2x. And you can see that if you make 80 cups, then that's where the two lines cross. That's when that's when your revenue and your cost have the same value. Now, you can see that as you sell more than 80 cups, that revenue function is increasing above the cost function. And you can see as you sell fewer than 80 cups, that's when your costs are above your revenue, and that's not good. And then on the right, you can see the profit function, what that looks like. And so that's 1.5x minus 120. And you can just see that as you cross over what would be the x-axis, and when you sell 80 cups, that means your profit is nothing. And then as you go to the right and you sell more and more cups, then your profit function is going above 0. Suppose that X represents the age of an adult in years and Y represents the systolic blood pressure in millimeters of mercury. Use the points 21, 118 and 51, 130 to write a linear model relating Y as a function of X. So basically, you can think of those as 2 points on this line, and you want to find the function, so the equation of the line. So you will use those values to find your slope. So 130 minus 118 over 51 minus 21, and that's going to be 12 over 30, which is 2/5. So that's going to be the slope of this line. So y equals 2/5 x plus b, and we don't know what b is yet. We can plug in one of those points for x and y, and that would be 118 equals 2/5 times 21 plus b. And if you get b by itself, you're going to get that b is 109.6. So your function now, your linear function, is going to be y equals 2/5 x plus 109.6. So that's your function that describes this line. So B says interpret the meaning of the slope in the context of this problem. The slope is the rate of the increase of your systolic blood pressure as you age. So your systolic blood pressure goes up 2/5 of a millimeter of mercury each year. And so for part C, use the model to estimate the systolic blood pressure for a 55-year-old. You're just going to put in 55 for X and see what you get. And that would be 22 plus 109.6, which would be about 131.6 millimeters of mercury.